Now that we understand solubility and how ionic things and acids behave in water, we can write chemical equations that more accurately show what's going on during a chemical reaction. Previously, we've always been writing the molecular equation. This shows everything as if the complete neutral formula of everything stuck together as intact units. So for instance, we might write sodium chloride aqueous. But now we know that an aqueous sodium chloride compound is not going to stick together in sodium chloride units. It's going to break apart into sodium and chlorine units. So we can rewrite molecular equations as ionic equations that more accurately depict the fact that aqueous ionic compounds and acids will ionize in solution. So in a complete ionic equation, anytime we have an aqueous compound, we break it apart to show the ions that it actually forms. Once we do that, we may find that there are certain molecules or certain species that just don't do anything. They move from the left to the right side, but they don't actually participate in the reaction. If we eliminate all of those, which are called spectator ions, we're left with a net ionic equation, which simply shows the things that are actually reacting in that setup. So let's look at an example. For this molecular equation, lead nitrate reacting with potassium chloride to form lead chloride and potassium nitrate, we can rewrite it to show how all of the aqueous, i.e. soluble compounds, break apart. So for instance, the lead nitrate would break apart into lead and nitrate, and notice we put the charge on each one of these as well as how many are generated. So since there are 2 nitrates in this compound, when it breaks apart, we end up with 2 right there. Similar, potassium chloride breaks apart into potassium and chloride. There's a 2 in front of the whole compound, so this gets distributed. That's why there's a 2 in front of the potassium and the chloride. The solid thing does not break apart. It is not aqueous, it is not soluble, so it does stick together as lead chloride. Potassium nitrate also breaks apart. Once again, we had a 2 out front, so since we had 2 compounds, that will generate 2 potassiums and 2 nitrates. And we always put the charge and the phase on everything. After we break all of the aqueous pieces apart, so notice solids, liquids, and gases always stay together, we can look and notice that certain pieces don't change. They just move from left to right. These are called spectator ions, and if we eliminate them and simply write what's left, we see what actually took place. This is the net ionic equation. In this big equation up here, the only thing that actually happened was that lead ions and chloride ions got together to form lead chloride. So now we should be able to write these for ourselves. Let's look and practice. Write complete ionic and net ionic equations for the following reaction. So we always start with complete ionic. This is where we break all of the aqueous pieces apart. And they're only ever going to break apart into 2 pieces. So if you see a longer molecule like this, it doesn't mean you're going to have 4 different ions. It should always break apart into 2. So the 2 pieces I have here, it starts with an H, so this must be an acid. So one of the pieces is going to be H+, and the other piece is going to be my acetate ion, C2H3O2-. Now there is a 2 in front, which means we get a 2 here and a 2 here. So we're going to add these together. We also add an AQ, which you probably can't see if I scribble, to both of these. So we put the phases. So this breaks apart into an H+ and an acetate. Next one, potassium carbonate. It's going to break apart after the potassium. I have 2 potassiums, so I'll have 2 of my K+. He's aqueous. That's an AQ right there. Now carbonate, notice it has a subscript, but carbonate is 1 unit. So I don't move that 3 around. I just write out the whole carbonate ion. He has a -2 charge. He's also aqueous. So both my aqueous guys broke apart. I come over here and I see liquid and gas. These are not going to change. Solids, liquids, and gases do not break apart. So I'm just going to rewrite them exactly as they are. And then my last aqueous piece. So I have a 2, so I'll end up with 2 potassium ions and 2 acetate ions. So this is my complete ionic equation right here. All of my aqueous things I broke apart to show more accurately how they're behaving in solution. To get my net ionic, I look back at my complete and I look at things that just went from left and right but did not seem to react or change at all. So in this case, my acetate ions just floated from reactant to product, and my potassium ions just floated from reactant to product. Those are my spectator ions. They just watched, they didn't do anything. So I can basically cross these pieces out, and then I'll write what's left, which are my 2 hydrogen ions, and my carbonate ion, and those form water, liquid water, and CO2 gas. That's my net ionic equation. So after I write my complete ionic, cross out all my spectator ions, whatever's left is my net ionic, and this shows me the species that actually participated in that chemical reaction.